Hi, in this problem, you see that we have to find that given complex number root 3 by 2 plus I by 2 and all that stuff, and it will be whole to the power 5. Okay. So, see, and also that what is the modulus of that? Because that's the easiest way to do, because obviously we cannot apply binomial theorem and we don't want that. So either you can use the exponential representation, or in other way we'll use here directly the de Moivre's theorem, okay, for the integers. Okay, so let's do that stuff first. Okay, so here it is given that first consider the complex number z1. So here we consider z1 is actually root 3 by 2 and plus I by root 2. I by 2, sorry. Okay, and the second complex number is the same thing with a minus sign. So z2 is actually root 3 by 2 minus I by 2. Okay. Now, let us calculate mod z1, mod z2, right? So, if I calculate that mod z1, we can see that this is actually equal to 3 by 4 plus 1 by 4 square root, which gives you 1, and similarly mod z2 will be equal to the same thing, right? Because that's a conjugate actually. So plus 1 by 4 and that's equal to 1. So z1 and z2 be the two complex number with modulus 1. So therefore, these two complex number can easily be represented as in the form of e to the power I theta, or maybe cos theta plus I sin theta. So let's write down that. Now you can see that with the basic class 9, 10 trigonometrical ideas, right? We know that root 3 by 2, if I write down into cos of theta, it will be pi by 6, because cos 30 degree is root 3 by 2. So therefore, the complex number z1 can easily be written as cos pi by 6 plus I sin pi by 6. And also by observation, we can find out that z2 is actually z1 bar. Okay, so they are complex conjugate of each other. So therefore, the complex number z2 can easily be written as cos pi by 6 minus I sin pi by 6. So that's actually my z1, and we have the z2 now. Now my problem is actually mostly solved. So let us calculate that z1 whole to the power 5. So z1 whole to the power 5 is actually cos pi by 6 plus I sin pi by 6 whole to the power 5. So here this should be pi. So let's consider it as pi. Now, what is the de Moivre's theorem? De Moivre's theorem states that cos theta plus I sin theta whole to the power n is actually cos n theta plus I sin n theta. But here we have to remember that here n must be integer. If not an integer, it's a different formula. So let's here obviously saying that z1 bar to the power 5 is actually cos pi by 6, 5 pi by 6, sorry, and plus I sin 5 pi by 6. And similarly, with application of the same de Moivre's theorem, we can find z2 to the power 5 is actually cos of 5 pi by 6 minus I sin 5 pi by 6. That's it. Now, what we ask, our complex number z is actually z1 to the power 5 plus z2 to the power 5. So let's take that. So z is equal to z1 5 plus z2 5. So therefore, if we add them together, we can see this is 2 times of cos of 5 pi by 6. And that's it. So there is no imaginary part of z. So therefore, we can consider that in this particular problem, that imaginary of z is actually 0. Or in other way, if we try to calculate the value of z, we can calculate it as well. Let's do that stuff. Okay. So here you can see that z is equal to 2 times of cos 5 pi by 6. That means it's pi minus pi by 6. So what is pi minus pi by 6? Pi minus pi by 6 means it is actually in the second quadrant, right? In the second quadrant sign. So therefore, we can say it is actually minus 2 cos pi by 6. And we say that whenever it is in second quadrant, right, it is minus pi by 6. And then it's done, right? Because therefore, we can say that also in this particular problem, real value of z is actually less than 0. So this is the two conditions, okay. But obviously you see that the real z condition is not required here because only one condition, that imaginary z is 0. So this for this particular problem, the correct option is B. Hope you understood the problem. And now just have a look in the detail so you can see that what is the correct choice, right? So that's it. Thank you.